Okay, so again, we're really just hitting the first half of this lesson today. There's more to triangle similarity theorems than just what we're going to see today, but we're just going to learn one of the theorems today. So it's sort of an intro. Do you remember? So this is our definition of congruent triangles. Triangles are congruent if all of their corresponding sides and angles are congruent, okay? So technically, to know that two triangles are congruent, you have to know all three sides and all three angles are congruent. But do you remember that we had some theorems that were sort of our shortcuts?
Yeah.
Okay, like what?
SAS.
Okay, there's one, yep. Sorry, I'm just looking for a color that'll show up, okay? So SAS was one of them, right? What else did we have? ASA, yep.
SSS.
Yep, SSS. What else? HL, good. And then there's one more. AAS. Yeah, we kind of combined that one with HL, so we didn't learn that one as a separate one. But okay, so those were sort of our shortcuts, meaning we didn't necessarily have to show like all 6 parts were congruent. We didn't have to show that all 3 sides and all 3 angles were congruent. As long as I had one of these combinations, I was good to go. Okay, make sure you get those jotted down because when I click the slide, it's gonna disappear. Everyone got those? Okay, so cool little bullet points, but that's all right. What does it mean? In the wrong order, but this again is a review from last chapter. Two figures are similar if the side lengths are proportional. So remember, if there's that k value, maybe next to proportional, let's write k value. Okay, if there's a k value between the sides, then if the angles are congruent. So remember that when we had two figures that were similar, and similarity was all last chapter. Okay, so that stuff that we just finished doing, that's what I was talking about when I said similarity. If two figures are similar, the side lengths had a k value, right? The length was adjusted by a k value, and all of the angles were congruent. Okay, so again, both of these things are just, I'm going to refer back to these later in the lesson, and so you want to make sure that you have those kind of fresh in your mind. Questions on either of those things as a review? Okay, so just triangle congruence, we have some shortcut theorems with similarity. And one of them is the SSS similarity theorem. Okay? Now, with triangle congruence, when we said SSS, it meant that all of these sides were equal to all of these sides. When we're talking similarity, are the sides necessarily congruent? No, but they are proportional. Okay? So when I say SSS, I'm not talking about these 3 numbers match these 3 numbers. I'm talking about, are these numbers proportional with these numbers? Okay? And so again, if you know that all 3 sides are proportional, you don't have to take that extra step of proving that the angles are congruent because it sort of follows. Okay? So let's say I give you these 2 triangles, and I say, are they proportional? Are the side lengths proportional? With triangle congruence, it was really easy to say whether they were congruent because you just had to have the numbers match, right? Now I don't have that, okay? I have to actually do some work. And there's 2 different ways I find that students like to do this. So I'm going to show you both, and then you pick whichever way you like better. First method would be to actually set up proportions, okay? So if I start with the 3, which side would have to correspond with the 3 over here? The 6, because it's the smallest, right? Okay. So 3 over 6. Okay. Which side would have to correspond with the 4? The 8. Yep. And which side would have to correspond with the 6? Obviously the 12. So what I want to know is it true that all 3 of these fractions are equal to each other? Okay. And so that one you can probably just look at and tell, right? Those are all equal to 1/2. But the other thing you could do is actually calculate them. Actually calculate like 3 divided by 6, 4 divided by 8, 6 divided by 12, and make sure they all come out the same. Okay, so this is what you're checking, is are all 3 of these equal? Jake?
How does 3 go 6?
The 3 here goes with the 6 here because it's the shortest side. So the shortest side here would have to go with the shortest side here. Okay? So that's how I'm lining those up. This is kind of the middle side. So the middle side over here would be the 8, and then this is the biggest side, so this is the biggest side. Okay? I would not rely on visuals here. Okay? I would not rely on like, oh, it looks like if I turn that triangle that way, that would line up with that. Rely on, is it the bigger side, the smaller side? How do they relate to each other? Okay? So that would be one way to do it. The other way to do it would be to find that K value. So again, if I know that this side is a 3 and that would have to correspond with this. I know Jake just asked, but is anybody else still confused about how I paired up the 3 and the 6? Okay. So I could take one of those pairs of sides and say, okay, what's my K value? My K value is 2, right? So then I could check, does that K value work for all my other combinations? So is it true that 4 times 2 equals 8 and 6 times 2 equals 12? Okay? As long as that same K value works for all of your combinations, you can say that they're proportional. So really what you want to make sure is that if you were to find a K value, it would turn all 3 of these numbers into all 3 of these numbers. Okay, that's what it means to be proportional. So when I give you 2 triangles or 2 sets of lengths and I say, tell me if these side lengths are proportional, that's what I'm asking you to do. Does that make sense? Hopefully. We'll practice that some more. Okay, just like congruent triangles, and I'll slide this over in a second, but just like congruent triangles, you have to be careful about how you name similar triangles. So take these 2 triangles and say I'm going to name the first triangle ABC. And I know those letters are a little bit, or those numbers are hard for you to see. Hopefully, did they show up on your paper okay?
Yeah.
Okay, good. Let's say I wanted to name these triangles. I want to say triangle ABC is similar. Remember, that's your symbol for similar. Let's think about how I would have to name that other triangle. Okay, if I started with AB here, is that my small side, my big side, or my in the middle side? That's my in the middle side, right? What's my in the middle side over here?
DF.
Okay, so I know that that one has to go with DF. And then I went to C, so from B to C, that's my big side, right? Does that make sense? That the one down here, that's my big side? So my big side here would be the 10, so I need to go in this order. Okay? So from D to F to E. So again, you just want to name them so that I can say side AB goes with side DF. Side BC goes with side FE. And side AC goes with side DE. Okay? Whatever way that makes the most sense to you. But just make sure they line up. Could we have named that first triangle differently? Sure. Yeah, we could have. But then we would have had to change how we named the second one. Good? Nothing new there, right? You're used to having to do that? Oh, that was in there. Okay. So, I'm giving you these 2 triangles, and I want to know, first of all, what ratios are equal to each other, which means basically I want you to set up the proportions. Okay? So let's start with the small side over here, the 20. The 20 would have to match up with what over in the other triangle? How do you know? Smallest side. Good. So 20 goes with 28. Okay. What other ratio could I set up then? What other 2 things could I pair up? 30 and 42. Good. Nope, doesn't matter. So could I have set that first one up as 28 over 20? Sure, as long as I did all the other ones flipped also. Okay, and then my last one would be 40 and 56. By the way, because these are proportions, remember you could also double check them by doing the cross multiplying. Like if I multiply these two, it should equal these two. And if I multiply these two, it should equal these two. Okay, so you could also check it that way. All right, if I name that first one triangle BAC, how do I want to name the second triangle?
YXZ.
Good, YXZ. Again, I would just kind of follow the path. So if I went from B to A to C, that's how I named that triangle. So I went along that middle side and then along the small side. So I would go from Y to X to Z. And I do find it helpful to do this sort of like either color code. If you have different colors, you could do different colors. Or do like a circle around this set and a square around this set and a triangle around the other. Okay, whatever you want to do. Or leave one of them not circled and know that those two pair up. Okay, give the measure of each angle in triangle BAC. Hold on, let me see if I can get rid of my junk over here. Oh, I don't want to erase all of that. That's okay. You can read them on your paper. Okay, what do we know about the angles if we know these triangles are similar?
They're congruent.
All the angles have to match, right? So I don't do that K value thing. I say if this angle is this, then the corresponding angle is going to be exactly the same. So let's see. Angle Y. Which angle is going to correspond with angle Y?
B,
How do you know?
because that's the way that the two were named.
Okay, so triangle B has to correspond with angle Y. So B is going to be 29 degrees. That didn't help like I wanted it to, sorry. Then I can't see my picture. Okay, what's angle Z correspond with?
C.
Z has to correspond with C. So angle C would have to be 46.5. And angle A then would have to correspond with angle X, which is 104.5. Good?
Yep.
That's really it for today. Okay? So SSS similarity, the sides are proportional. Okay? And the angles all match. A board is section 13.1, which is page 741. Numbers 2, 4 through 12, 14, and 15. Okay, not too bad. And you've got probably half an hour to work on it right now. Okay, so go ahead and get to work, please.